Memory management in Java is a fascinating topic that truly showcases the elegance of the language. At its core, Java uses a combination of stack and heap memory to manage data efficiently. Let's dive into how this works. First, let's talk about the stack. The stack is where Java stores local variables and method calls. Think of it as a temporary workspace. When a method is called, a new block is created on the stack, and when the method finishes, that block is popped off. This means that the memory used by local variables is automatically reclaimed when the method exits. It's fast and efficient, but it has its limits. The stack is typically smaller than the heap, and it can lead to a stack overflow if too many method calls are made, like when you have a recursive function that doesn't have a proper base case. Now onto the heap. The heap is where objects are stored, and it's much larger than the stack. When you create a new object in Java, memory is allocated from the heap. This is where things get interesting because the heap is managed by the Java Virtual Machine, JVM, through a process called garbage collection. Garbage collection is like having a dedicated cleaning crew for your memory. When you create an object, it remains in the heap until there are no more references to it. At that point, the garbage collector steps in to reclaim that memory. This process is automatic, which is one of the reasons Java is so popular. It reduces the burden on developers to manage memory manually, unlike languages such as C or C++. However, garbage collection isn't without its quirks. The JVM uses different algorithms to determine when and how to collect garbage. Some of these algorithms are generational, meaning they categorize objects based on their lifespan. Young objects, which are likely to become unreachable quickly, are collected more frequently than older objects. This approach optimizes performance because it minimizes the time spent on garbage collection. But what happens during garbage collection? The JVM pauses the application to identify and clean up unused objects. This can lead to what's known as stop the world events, where the application temporarily halts. While this is generally brief, it can impact performance, especially in applications that require low latency. Memory allocation in Java is also an interesting topic. When you allocate memory for an object, the JVM looks for a free block in the heap. If it finds one, it marks it as used and returns a reference to the object. If there isn't enough contiguous space, the JVM may need to perform a process called compaction, which rearranges objects in memory to free up larger blocks. This is where things can get a bit complex, but it's all part of keeping memory usage efficient. In summary, Java's memory management system, with its stack and heap, along with the automatic garbage collection, makes it a powerful tool for developers. It abstracts away the complexities of manual memory management, allowing us to focus on writing code rather than worrying about memory leaks or allocation failures. Understanding these concepts not only helps in writing better Java applications, but also gives insight into how the JVM operates under the hood. It's a blend of efficiency and automation that truly makes Java stand out in the programming world.